Today we're going to, in Chem 100, we're going to cover chapters 4 and 5 review for exam number 2. And that exam will be due on next Tuesday. Today is Thursday, the 9th. So it'll be due on Tuesday, the 14th. All right, so I've got the review document here, and I've highlighted some problems, and a few of them are repetitive, but most of them are not. And that doesn't mean you should only focus on these. If you want to master chemistry, do the whole document. Let's get started. This is chapter 4. And number 1. What's the symbol for the element iodine? All right. You should have prepared your flashcards and learned all of those 60 some odd elements that I outlined on the periodic table entitled Know These. All right, so that's the symbol for iodine. It's one of those that derives from the English, or appears to derive from the English, and it's only got a single capital letter. How about lead? Lead is one that's derived from the Latin, and it has two letters in the symbol. The first one's capital, the second one's small letter. And that's the pattern always. If there are 2 letters, capital, small. Right? That's lead, Pb. That's the Latin word, plumbum. Let's see, who's next? 3. We'll run through a few of these. Which of the following elements is an alkali metal? Remember, the alkali metals are the first column on your left of the periodic table. So you go to your periodic table and you compare these and see which one is in that column, right? And it turns out that sodium is the only one that's in that column, right? Along with its neighbors like lithium, sodium, potassium, rubidium, cesium. They're all alkali metals. But 4, an atom with 45 protons has a mass number of 100. So we've got an element here. We're going to use that symbol for now. 45 protons and a mass number of 100. How many neutrons does it have? Remember, the mass number is equal to the number of protons plus the number of neutrons. So if you subtract the number of protons from this value, you'll get the number of neutrons. So we have 55 protons. Neutrons, excuse me. Neutrons. There we go. And 5. What's the most abundant element in the human body? Well, that's kind of a misleading question, because are we talking about the most abundant by numbers of atoms or by mass? Right? By mass, definitely yes, because the body is predominantly water. We're mostly water. And water, of course, has oxygen and hydrogen in it. And hydrogen weighs 1/16 of oxygen. but 2 of them would be 1/8. So if we're talking about mass, definitely oxygen. If we're talking about numbers, what other elements? The hydrogens would outweigh the oxygen. So based upon the answer that's given, I would say the abundance here is in terms of mass. Well, it doesn't erase too well. I'm going to switch colors for now. Let's try brown. And the next one is 7. Here's another one that you should have memorized. The symbol for copper. Copper is one of those derived from Latin. Copper. All right. How about this one? Number 10. An atom has 54 protons, 54 electrons, and 78 neutrons. What is it? If you know the number of protons, you know the element. Because the number of protons is unique to every element. So 54 protons, look on your periodic table, and 54 makes it xenon. All right. Let's see. I'm going to have to scroll this one myself manually. Let's see. We get those two. Number 12. How many neutrons are there in one atom of? Okay, so this is kind of redundant. We've had one like this before. So we know to calculate the neutrons, except for this one, we're not told how many. We're just said for this symbol and these values, how many neutrons. You have to know that this position is equal to Z, or the number of protons. And this position is equal to A, or number of protons plus the number of neutrons. So now once you have that information, it's simple. 45 minus 21 is 24 neutrons. I'm going to switch colors again. Let's try blue. Number 13. There we go. And we kind of lost that one. Let me see if I can do this. Yeah. All right. There we go. Number 13. Which of the following is a noble gas? This is like that one we had for the alkali metals. You have to know where the noble gases are located in the periodic table. The far right column, farthest one to the right. Those are all noble gases. So you just compare. And if you don't already know, right, if you don't have your noble gases memorized as a group, then you look down through there and you're going to find that argon is the only noble gas in that bunch. $14. The chemical formula Al2O3. Al2O3 indicates how many atoms of each element. Let's see, we have 2 aluminums. And 3 oxygen in that formula unit. So that means it's C. C is the answer right there. Let's see, we're going to do 15 also. SI is the symbol for what? Okay, that's one of those that's derived or is can be thought of as derived from the English, right? Silicon. How about this one? 17. How many of the following did Dalton not discuss in his atomic theory? Read those questions carefully. Some of them are written in the positive and some of them are written in the negative. This one's in the negative. How many of these are not discussed in the atomic theory? So which one of these let's see, which one of these particles did Dalton not know about? Think about that. Right? He didn't know about isotopes, definitely not, because he thought all atoms were exactly the same. Did you know about ions? No, they didn't know about ions yet either. They didn't know about any of the subatomic particles during Dalton's time. So none of these, all 5 of them, were not included in Dalton's atomic theory. Dalton just thought atoms were bags. He thought that each atom was different for each element, but he had no idea about any of these other characteristics or particles that were part of atoms. All right, let's scroll again. 20. And 21. The number of neutrons in beryllium. Okay, this takes some detective work. The number of protons is easy. We just look on the periodic table and find that beryllium has 4 protons. But how do we know how many neutrons? Because there may be isotopes. There probably are isotopes of beryllium. So we look at the periodic table and find that what we have is the atomic mass given as not a whole number, but a fractional number. And that for beryllium is 9.01. 9.01 is the atomic mass. Okay, remember how we arrive at atomic mass? It's the weighted average of all the isotopes in the naturally occurring beryllium. So if we've got an atomic mass here is the average value, 9.01, then the vast majority of the isotopes of beryllium are going to be 9. And since it's a little bit more than 9, you can assume that the next highest would be 10. Beryllium 10, there might be just a fractional amount of those. So we're going to work with the most common isotope, 9. So that means that it has 5 neutrons in that isotope. That's how we arrive at this answer. Okay? All right, 21. Which of the following is a non-metal? In order to determine this one, you've got to know where that black line, that stair-step line is in the periodic table. If you get it wrong, then you're going to put metals on the non-metal side or non-metals on the metal side and get this one wrong. So the stair-step starts under boron, right? Goes like that. So the next one down here would be germanium, and the next one over here would be silicon. So you just keep going stair-step like that. If you start it correctly and do the stair-step, then you'll be fine. But now you look on your periodic table and say, all right, which ones of these is a non-metal? Well, we know that that's a metal. Copper is a transition metal. Calcium is an alkaline earth. Cesium is an alkaline metal. Cerium is an alkaline, cerium is a lanthanide. Carbon is the only one that's a non-metal in this group. All right, 23. The symbol for the element mercury, right? Mercury is one of those that's odd, right? Derived from the Latin. And the symbol is Hg. And actually, it's a built-up word. Hg stands for hydrogenium. Right? There's the H, there's the G, which means water producing or water creating. So apparently mercury was associated in some form or fashion in the dim past, maybe in the Middle Ages, was associated with production of water. '24. The symbol N stands for what element? Right? You've got several of them in here. What is N? They've got N for nickel. What's nickel? Nickel is that. What's nobelium? Nickel is, I believe it's that. No, I don't know. Nobelium is let's see, scratch my head. Now, I'm curious, I'm going to find out what it is. That's number 24. Well, it doesn't say. I'm thinking nobelium might be NB. Anyway, niobium is not Ni, that's nickel. Niobium would be, I think NB is niobium. And then neon is Ne, nitrogen. That. Now, why does nitrogen get an N and everybody else has to go 2 letters? Because nitrogen was here first, right? It staked out that letter for itself before any of the other elements were discovered. '26. Choose the pair in which the components have the same charge. Okay, let's do this one at a time. So a hydrogen atom and an electron. Hydrogen atom is neutral. Electron is a negative charge, so it can't be that one. How about an electron and a neutron? Nope, not the same charge. Neutron and a hydrogen atom. Yep, they are exactly the same charge. They're both neutral. We can go ahead with the other ones. Proton and hydrogen atom, nope. Proton and neutron. Nope. This is the only one where the charge is the same for both of these components. Six. 28. The number of protons in the nucleus of an atom is called its what? That's just definition, right? This is the atomic number. And we often give it the symbol Z. About 29. Which atomic particle determines the chemical behavior of an atom? You might be tempted to say the proton, because the proton determines the element. But when you're talking about chemistry, chemistry is determined by how elements interact. So when we think of it in those terms, what's the first thing that two atoms see when they approach one another? They don't see protons, they see electrons. The electrons determine the chemical behavior. Let's see, scroll again. 30 and 31. What's the most abundant element on the earth, including the crust, oceans, atmosphere? And here we go again. We're thinking in terms of mass or numbers of atoms. I think it's mass. I think that's what they're talking about here, mass. And in that case, including the crust, oceans, and atmosphere, oxygen would have to be it. In the crust of the earth, most of the elements are combined with oxygen. We don't have any free elements. Well, there are a few. Right? The noble metals like gold can be found as pure elements. But most of them are combined with oxygen in some form or fashion. Oceans, that's a no-brainer. Oceans are made of water and some other things. H2O. So the mass there is due to that water molecule. And the atmosphere? Well, the atmosphere is 21% oxygen. Right? So when you combine that with the rest of them, oxygen has to be it. 31. An atom with 15 protons and 16 neutrons. Right, so that would be what? 31 would be up here. We may need that, we may not. Is an atom of what? We don't need that. All we need is the number of protons. So 15 protons is the atomic number. And that means we have phosphorus. Okay? All right. 33. Got some detective work here. A certain isotope has a 2+ charge. So that's what? That's an ion. It's an isotope, yeah, but it's also an ion. Has 37 electrons and 73 neutrons. Okay, what's the mass number for the element? We can't just add these together, right? Because we don't know. We cannot assume that this is the same as the number of protons because we have an ion. How do you get an ion? You make an ion by either adding or subtracting electrons. You don't touch the protons. If you change the protons, you change the element. So to get an ion of an element, you change the number of electrons. And if we got a 2+ charge, that means we have 2 more positive charges than negative charges. That means we have 39 protons. That gives us 2 extra pluses. Now we can add these together. And we can find that the mass number, the mass number is 3 and 9 is 12, and 1 and 10 is 11. So that's equal to the mass number. $37. And let's see, let me get that out of the way. There we go. How many phosphorus atoms are represented by one formula unit of cobalt-2 phosphate? Isn't that nice? They gave you the formula. They make you write cobalt-2 phosphate to deduce what is the formula. This is cobalt-2 phosphate. Okay. Question is, how many phosphorus atoms are there? Right. Well, we have one phosphorus for each of the phosphates, but we have two phosphates. So there are two phosphorus atoms represented by that unit, by that formula. All right, 39. Is this a similar one? How many atoms are represented by one formula unit of aluminum chromate? So they're giving us the formula. There we go. How many atoms? Well, we have 2 aluminums, 3 chromiums, and 12 oxygens. So 2 aluminums, 3 chromiums, and 12 oxygens. That's 17. 17 atoms are represented by that formula unit. All right, let me scroll up just a hair. Yeah, that'll be good. Number 40. We're still in chapter 4. Which of the following statements are true? Well, let's see. 1, 2, 3, and 4. Okay. How about the first one? Models are always wrong unless they are proved by a theory. Is that true? As a matter of fact, the theory is created first, and the model is developed to help support the theory. Right? So this one is false. Elements such as lead are made of tiny particles that mostly consist of open space. That was worded. It's not worded the best possible. What they're trying to say is atoms are made of tiny particles. Yeah, the atom is itself mostly space. So the elements consist of open space, and they're made of tiny particles. That's what they're trying to say there. And that is true. The air you breathe is an example of a heterogeneous mixture. Is that true? What have I said from the beginning? When you mix two gases, you always get a solution, a homogeneous mixture. This one is false. You never get a heterogeneous mixture when you add gases together. And 4, because ammonia always contains the same relative number of atoms, it will always contain 4.6 grams of nitrogen for every 1 gram of hydrogen. Okay. Have we gotten far enough? Let's see. Yeah, we can deduce this one. Yeah, we can deduce this one. This is a way of stating the law of constant composition or definite composition. In other words, all compounds, no matter what their origin, for each compound, no matter where you get it from, the ratio of masses of elements is always the same. So let's see if that's correct. So the ratio then would be, what's the atomic weight of nitrogen? Well, if we got this compound, and the atomic weight of nitrogen is 14.01, and we have hydrogen, but there are three of them, 1.01. Okay, so this is 3.03 is ratioed to 14.01. All right, so look at this. They're saying 1 gram of hydrogen. This is 3 grams. This is 3 grams per mole. So if we divide 3.03 into 14.01, let's see if we get that ratio. Yep, 4.6, the same ratio, 4.6 to 1 is nitrogen to hydrogen. That's a true statement. So B is the answer. 4 and 2 are true. All right, 42. Which pair have approximately the same mass? Well, test taking technique. When you have multiple choice question and you have answers that are unique for every one, you don't have any oddballs in there like 2 of the above, none of the above, all of the above, whatever that case may be. If each answer is unique, then you can work your way down, and when you find the right answer, you can stop. So which has approximately the same mass? Protons are approximately the same as neutrons. Let's see, mass of. That first one is true. So we can stop. That's it. That's the answer. How many nitrogen atoms are indicated by the formula AlNO3? 3. Oh, excuse me, 2. Is that right? That's correct. Okay, how many nitrogen atoms do you have here? Well, you've got 3 nitrites with 1 nitrogen each. So you have 3 nitrogen atoms. Let's see, how about 48? How many protons are in the atom carbon? All you have to do is look it up on the periodic table. What's the atomic number? That's the protons. And carbon has 6. 6 protons. Um, 51, symbol. What does SN stand for? Well, it's one of those Latins, right? SN stands for stannum or tin. Okay. Sodium is Na, sulfur is S, strontium is Sr, and silicon's Si. So there's no way to guess your way out of that one. You just have to know that Sn is 10. How many protons, electrons, and neutrons respectively does 45 Sc2 plus? 45 Sc2 plus. So we want protons, electrons, neutrons. Protons, electrons, neutrons. How do you find that? Well, unless you know the number of protons, you know the atomic number, you're stuck. But if you know the element you can find the protons. You just look up SC, scandium, and you'll find it in the transition metals. In the fourth period, transition metals, it's the first one when you go from potassium, calcium, scandium, scandium. So scandium has how many protons? 21. Now we can do it. 21 protons, 21 from 45, 24 neutrons. How many electrons? Well, same problem as before. We have 2 extra protons than we have electrons, right? So we're starting off with 21 electrons if it's neutral. 21 electrons if it's neutral, but we need 2 extra protons. So this has to be knocked down by 2. 19 electrons will give you an excess of 2 protons. So 21, 19, and 24 is B. '61. The average mass of boron atom is 10.81. 10.81 is the atomic mass, the atomic weight. Assuming you were able to isolate only 1 boron atom, you can pick 1 boron atom out of a collection. The chance that you would randomly get one with a mass of that number, atomic mass units, what is the probability of finding an atom of boron with that mass number? The probability is 0, because that number is a weighted average of all the isotopes in a naturally occurring sample of boron. There's no atom in there that's exactly that mass. '65. Which of the following elements is most similar to chlorine? All right. So you find chlorine in the periodic table. And where are its similar neighbors? Who's member of the chlorine family? You know that chlorines are halogens, and all the halogens have similar characteristics. So the halogens are like fluorine, chlorine, bromine, iodine, and astatine. Sorry, that's arsenic. Astatine. So, which one of those is in here? There's bromine. Right? It has a similar behavior to chlorine. Let's see, 70 and 71. 70. How many protons, electrons, neutrons are in 31 phosphorus? Okay. This is like before. Protons, electrons, neutrons, right? In that order. Protons, electrons, neutrons. So you look up phosphorus in your periodic table. It has 15 protons. It's neutral, so it has 15 electrons. Subtract 15 from 31, you get 16 neutrons. So 15, 15, 16 is the answer. And that's 71. Which of the following contains the largest number of oxygen atoms? All right. So A, B, C, D, and E. First one is 4 H2O. How many oxygen atoms are there? Well, we have 4 molecules with 1 oxygen each. 4 times 1 equals 4. This one is ozone. there's only one of them, right? 3 times, let's see. Yeah, 3 times 1 equals 3. H2SO4. We just count them up. There are 4. 3 CO2. So we have 2 here times 3 equals 6. And AlNO3 taken 3 times. So this one has 1. And this nitrate has 3 each, but there are also 3 of those. So that's 9. The most oxygen atoms represented by each of these formulas and their coefficients gives us the greatest number for aluminum nitrate. Oops, I skipped one. 70, 72. Scroll. There we go. 72. How many atoms of oxygen are in one formula unit of calcium dihydrogen phosphate? Right. This one, you've got to be able to write that formula yourself. We know it's got calcium in it. And dihydrogen phosphate is a polyatomic ion. Right? So it's dihydrogen phosphate, like that. So you go to the list of polyatomic ions that you will have access to in the same folder where you find the exam. There's useful information. Be sure to print that out first. And then when you go into Brightspace, Respondus Monitor, and Lockdown Browser, you'll be locked out of that, but you'll have a copy of it. And you look at that chart and you find that H2PO4 has a -1 charge, whereas calcium is an alkaline earth. Second column, it always has a 2+ charge. That means we need 2 of these units to balance that calcium. Okay, now we can answer the question. How many atoms of oxygen? Well, we have 4 here, but there are 2 of them. So we have 8 oxygens. $75. Which of the following statements is true? Okay, we got 3 statements. All right, number 1, the number of protons in an element is the same for all neutral atoms of that element. Yeah, that's true. The protons determine the element. So 1 is true. 2, the number of electrons in an element is the same for all neutral atoms of that element. That's true also. Because if the element is neutral, then the protons and the electrons balance, they're equal. And for every element, for every atom of that element, they have the same number of protons, so they have to have the same number of electrons. This is also true. How about 3? The number of neutrons in an element is the same for all neutral atoms of that element. That is false. Why? Isotopes. So 1 and 2 are true. Only 1 and 2 are true. Let's see. 76. Oh, we're into chapter 5 now. All right. But they're numbered sequentially. So 76 is our next one. All right. The correct formula for carbon monoxide. So this is, remember, chapter 5 was nomenclature, naming compounds. that last one was in chapter 4, and we had to know the name of the compound, so I think it was out of place. Probably should have been in chapter 5. The correct formula for carbon monoxide. So if you've got carbon and oxygen, what's the rule? Is that a type 1, type 2, or type 3? It's a type 3 compound because both elements, it's a type 3 binary, both elements are non-metals. That means you just say how many of each one there is. All right, so carbon being the first one, we don't say mono, so there's only one of them. Monoxide means there's one of them, that's it, CO. 77. Which of the following is a binary compound? Okay. This question is working off of the textbook author's definition of a binary compound. That means that you can only have 2 elements. Okay. So which one only has 2 elements? This one right here, H2S. That's considered a binary compound. Now we stretch that definition to include polyatomic ions because the polyatomic ion behaves as a single unit. So I consider those binary also. But your author's definition says that one. That's the best answer. '79. The correct name for an aqueous solution of HC2H3O2, aqueous solution. Right? So you've got 3 or more elements here. Actually, I have 1. Yeah, you have 3 elements: hydrogens, carbon, oxygen. And the first one is a hydrogen. That means this is an acid. Okay, that's the first clue. The next clue is you've got 3 elements and one of them is oxygen. That means that more than likely that is a polyatomic ion. Okay, so you go to your chart and you look it up, and sure enough, that is the acetate ion. Right there. Okay. Now that you know that it's an acetate and it has oxygen in it, how do you name the acid? If there's oxygen, you do not start with hydro. You simply go to the polyatomic and 8 becomes ic. So this is acetic acid. That's it. '80. Sodium represents Na plus. Represents what? Now we're getting picky. That is sodium. But is it an atom? No, it's an ion. This is a sodium ion right here. Okay. 81. The name for Hg2 2+ is what? Well, we know it's going to be an ion, right? So we look, see, okay, everyone is named is an ion. So now we have to say, what is that? Well, it's not hydrogen, but it is mercury. But remember, we cannot say mercury ion because mercury is one of those metals that has the possibility of different charges. We have to determine the charge. So the charge on this whole group is 2+, but there are 2 of them. So each one has a 1+ charge. So this is mercury one ion. All right. Okay. 82. What is the correct name of the compound that results from the most stable ion for sulfur? We're going to have sulfur in there. And the metal ion that contains 24 electrons. So this one has 24 electrons. Metal first, non-metal second. Okay. The most stable ion for sulfur, it's in the oxygen group. It's a chalcogen, which means it's a 2- charge. The most stable ion for that one is 2-. Okay. Now, in this case, we have to assume, well, let's see, if we have 24 electrons, we need to know what the charge is here in order to determine how many protons, right? Because we can't tell the charge unless we assume also that there's only one metal atom. We have to assume that. It's the only way. So if this is a 2-, this has to be a 2+, which means 26 protons. 2 extra pluses. So 26 protons means iron. That's 2-, that's 2+. So FeS. Oh, it wants the name. Okay, so iron 2 sulfide. Right there. $83. The symbol for the rubidium ion. All right, so we need the symbol for rubidium first, and we find it in the alkali metals, first column. That means it will always have a +1 charge if it's an ion. Right here, it says it's an ion. So that is the ion right there. $84. What's the correct formula for barium hydroxide? Well, we know we're going to have barium. And are there any elements by the name hydroxide? No. Hydroxide is a polyatomic ion. So you go to your chart, look it up. So what is hydroxide? Hydroxide is that. It has a -1 charge. What's the charge on barium? Depends on where it is, right? So we look at our table, we find that barium is an alkaline earth, +2 charge. That means we need 2 negatives to balance that 1 positive. So BaOH taken twice is the correct formula for barium hydroxide. Let's go ahead with 85. 85. The correct formula for lead 4 nitrate. We're going to have lead. It's got a 4+ charge, and we have nitrate, which is a -1 charge that you find in your polyatomic list. So in order to balance the charges, we need 4 of those. And we don't need the charges when we write the formula. So this one is D, right here. 86, let me scroll down. Then do 86 and 87. The name of the acid, HNO2. All right, we know it's an acid because they told us, plus it's got the hydrogen. but this has oxygen in it. So you cannot start the name with hydro. You have to work from what is that? That is nitrite. And ites become us. So this is nitrous acid. Right there. Let's see, 87. The correct formula for the ammonium ions. You can look it up or you can memorize it. Ammonium is NH4 with a 1+ charge. Right there. Let's see, let me scroll a little bit, see how many of these I can get on here at once. That's good. 88. The name for ALOH, taking threes. If we're going to name the compound, we have to know what type it is. Type 1, type 2, type 3. If there's a metal there, right, it's either a type 1 or a type 2. Then you have to decide between the two, is it a fixed charge or a variable charge? And aluminum is always 3+. Right? We can determine that from this too, because the hydroxyl is a minus, so 3 minuses makes that 3+. But since it's a type 1, we don't have to say what the charge is. That would be redundant. All we have to say is aluminum hydroxide. And that is unambiguous and not redundant. We can write that formula from this name just as easily as we can write the name from the formula. 89. The correct name for an aqueous solution of HCN. All right. So that doesn't tell us anything but the formula. So if this was an aqueous solution, what are we looking for? Well, is it an acid? Yeah. It's got a hydrogen right there. So we have to say, what is this? This is the cyanide polyatomic ion. Okay. But there's no oxygen there. So this acid starts the name with hydro. And ides become ics. Cyanic acid. Hydrocyanic acid is the name of that compound. Right there. Let's see. Okay, we got both of those on there. 91. Which of the following is named correctly? Okay, so this takes a little more work. D and E. So we've got 5 unique answers. That means when we find the right answer, we can stop. So the first one, HCl. If this is non-aqueous, it would be what? Hydrogen chloride. But if it's aqueous, it's hydrochloric, right? I becomes ic, hydrochloric acid, right? That's not it. That's wrong, right? How about the next one? HNO3. This one has oxygen in it, and that's a polyatomic ion, right? So this group is nitrate, and 8s become X. And we don't start with hydro. So this one is nitric acid. That's correct. Right. We can stop. We've found the correct answer. (92). The substance ClO3 minus is best described as what? Well, look at our choices. It's not a compound because all compounds are neutral. So it's an ion, some kind of ion. It's not a mixture. It's not a molecule. So it's either, and it's not a molecule here, so it's got to be this one. It's a polyatomic ion. And let's scroll so I can get those two together. Yeah, 97. Sodium chloride as the formula. We know we got sodium and chloride. Read carefully, because if you read too fast, you may say sodium chloride, in which you would say, you would write this, but that's wrong. Chloride, remember our sequence. ClO3 is chlorate. ClO2 is chloride. It's a -1 charge, +1 charge there. So NaClO2 is sodium chloride, right here. The correct name for an aqueous solution of H2SO4. All right. We don't start with hydro, so we have to know what is that. That is sulfate, polyatomic ion. So 8s become X. Only we modify it just a little bit. Sulfuric rather than sulfic. Sulfuric acid is the name for that compound in aqueous solution. All right, 101. The formula for the compound formed from the polyatomic ion ammonium and phosphate. Okay, what would be the compound formed from these two? Well, they are fixed charges, both of them. So we treat them like type 1 compounds. We just balance the charge. This one's a 3-. This one has, we need 3 pluses, right? So that means we need 3 of those. So NH4, taken 3 times, PO4 is our compound, right here. That's the formula. (103). Aqueous solution of HCl. Okay. This aqueous, I think we got one of these before, but it was in a combination. So this is, it starts with hydro because there's no oxygen, and chloride becomes ic, chloric acid. Okay. 105. How do we name this compound? Well, first of all, what type is it? It's 2 nonmetals. It's a type 3 compound. So we just say how many there are. This is phosphorus. Okay. And we never say mono for the first one. So it's just phosphorus, triiodide. Right there. (107). The name of PB4 plus. PB4 here, 4 plus. Well, we know that's lead, right? And we know it's an ion. But what type? Is it a type 1 or type 2 metal ion? It's a type 2 because lead can have multiple charges. It can have variable charge. And we find it on the periodic table, not in the transition metals, but over in the representative area. The representative area below the nonmetal, so it's still a metal. And with that 4 plus, we must say what the charge is. It's a lead 4 ion. Right here. (111). What's the formula for selenium trioxide? Well, this is a giveaway. If this is the correct name, and we've said how many oxygens there are, this must be a type 3 compound. So we just need to know selenium, which is 1, only one of them, and then 3 oxygens. Okay. So it should be right there. Now notice, selenium and oxygen are in the same family, same group. If either one of them were combined with a metal, then either would have a 2- charge. But when they're combined with each other, charges don't matter because these are covalent compounds. They share electrons, right? So we can't say that this one has to be a 2-, that one's a 2-. So why is there 3 of them? Right? It doesn't work that way. Not for a type 3 compound. Just a word of caution. These are both non-metals. All right, 115. Which of the following compounds is not named as an acid? All right. The quickest way to get to the answer here is if it's not an acid, it will not begin with a hydrogen. That begins with a hydrogen. Hydrogen there, hydrogen there, hydrogen there. This one does not. Ammonia is in fact a base. Right? So B is the one that's not named as an acid. 117. Okay, gold 1 oxide. So what's the symbol for gold? AU for aurum. And then oxide. So we have AU, and it has a 1+ charge. Right? Gold is one of those transition metals that has variable charge. And then oxide, which has a 2- charge. So we need 2 of these. Right? So we would write it like that. AU2O. Right here. (121). The carbonate ion has a formula CO3 2-. All right, CO3 2-. What is the correct formula for sodium carbonate? What type of compound is that? Look at the metal. Where does the metal come from? Sodium is an alkali metal, always +1 charge. Right? So we need two of them, two positives to balance these two negatives. And that's the way you would write the compound. Right there. All right. Let me scroll this one so we can put two of them on the same page here. There you go. 124. Which of the following represents the hypochlorite ion? Remember that sequence I gave you before. 3 minus, ClO2 minus, ClO minus. This is chlorite, chlorate, excuse me. This is chlorite. This is hypochlorite. Or you can look it up in your table. ClO minus, which is D. 125. How about that one? What's the formula for calcium hydroxide? Didn't we do this one before? Calcium hydroxide, that's a -1. This is a 2+. That's an alkaline earth. This is a type 1 compound with a polyatomic. So we need two of these hydroxides to balance the charges. That's the way you would look for it. Right there. All right. How many of these can we get on the same page? Maybe. Here we go. 127. The name for HBRO. HBRO. Right? This is an acid, and it has an oxygen in there in this polyatomic. So what is that polyatomic? Remember when I was showing you that list of chlorate, chlorite, hypochlorite, perchlorate? I said you could also substitute any of the other halogens in there. Well, you could substitute bromine, you could substitute iodine. In this case, this would be hypobromite. Right? We don't start the name with hydro. We don't say hydro, hypo. We say hypobromite, and ite becomes us. So that becomes us acid. So hypobromous acid would be right here. (128). The name for H2SO3. Here we go again. We don't start with hydro. We look to the polyatomic. This is sulfite. So ite becomes us. And we just say sulfurous acid. That's it. Right here. And 129, the correct name for P2O5. What type is this? 1, 2, or 3? You've got two nonmetals. That means it's type 3, and all we have to do is use the Greek prefixes for how many of each. So we have di, phosphorus, pentoxide. Notice I dropped the A out of that. Diphosphorus pentoxide, which is right down here along the bottom border. (127), 128, 129. 132, got that one on there. The correct formula for silver iodide. So we got silver and we've got iodine. Right? So what's the charge on silver? Okay. Silver is one of those transition metals that has a fixed charge. And it's a +1 charge. Iodine is a halogen, -1 charge. So that is the formula right there. AgI. 140. Correct formula for lead 2 sulfite. Lead 2+, says so right there in the name. And then sulfite, SO3 2-. Right? So these balance with just one each. PbSO3 is the correct formula here. (142). The correct formula for the carbonate ion. That was given to us earlier. You just look that one up. CO3 2-. A compound contains an unknown ion X. It has a formula XCl2. The ion X has 20 electrons. Okay. What's the identity of X? Okay. This is fairly specific. We're told that there's one of these for every 2 of those. That means chlorine is a halogen with a -1 charge. So that means this one has to be a 2+ charge. Okay. If it's got a 2+ charge, that means it has to have 2 more positives than negatives. That means 22 protons, right? So 22 protons is titanium. To answer the question, it's Ti2+. That is the identity of X, Ti2+. All right, what's the name of this one? NaHCO3. Well, here's your metal, and here's the polyatomic ion occupying the nonmetal position. So this is a type 1 compound, and you need the charge on this one, which is a -1. That's a +1. So it's just sodium. And the name of that is hydrogen carbonate. Okay. That makes it this one. Now this is added in there because that's the trivial name. That was a name prior to the standardization by IUPAC. Let's see, 148. The correct name for an aqueous solution of H2CO3. Aqueous. That means acid. Right? We have oxygen. Don't start it with hydro. We need to know what this is. That's carbonate. Right? H become X. Right? So we have carbonic acid. Right here. And that's one of the acids that's in every bottle of pop. Carbonic acid. That's what makes it fizz. Oh, 153. Name another one. NH4Br. Okay. This is a polyatomic ion. Right, look it up. This is ammonium. It has a fixed charge. Bromine is a halogen with a -1 charge. And they're balanced, one for each. Ammonium bromide. Right here. You don't say ammonium 1 bromide because that is redundant. Ammonium always has a +1 charge. So you don't repeat it. If you do, then it's wrong. 155. The formula for a compound formed from ammonium and sulfate ions. Okay. There's your sulfate, there's your ammonium. All right, so if we got a 1+ charge here and 2- there, we need 2 of these. So NH4 taken 2 times SO4. Right here. All right, that's it.